Hi, I'm Simon Hanover, a sophomore environmental engineer at the University of Wisconsin-Madison, and today I will talk to you about the background details of the Columbia Space Shuttle incident.
I'm Brian Brady, and I'll be covering the technical aspects of why the Columbia Space Shuttle failed.
I'm Jonah Nick. I'm a freshman in engineering physics, and I'll be analyzing the ethics and the risk associated with the space shuttle program.
Now, the Columbia Space Shuttle disaster was the largest loss of life in any single space incident. However, before we learn about why this happened, we need to learn a bit more about the background of not just the Space Shuttle program, but also the position that the US was in at this time. The US was in a bit of a precarious position in 2003, given this was 2 years after the 9/11 terrorist attacks. So, and this was the largest loss of life on US territory in a non-natural disaster related incident since the Civil War and the first attack on American soil since World War II. And because of this, people were rightfully feeling a little bit scared, a little bit vulnerable, a little bit anxious and distrustworthy of the outside world. And on top of this, the war in Afghanistan had started a couple years prior, and the war in Iraq, while not starting at the beginning of 2003, would start in the incoming months. And while most of the U.S. was behind the war on terror, this also caused some division within the United States. However, there were still some optimism being gained in 2003. The economy was or the inflation was at a 10-year low, and the economy was starting to rebuild from the 9/11 attacks. And despite the discourse between these war on terror, the US was overall still fairly united, given, as you can see by George Bush's approval ratings. While not nearly as high as they were after the 9/11 attacks, they were still fairly high and showed the general unity of the American people. Now, the Columbia Space Shuttle program was the 113th Space Shuttle mission, and it was flown out of the Kennedy Space Center in Florida on January 16, 2003. The Space Shuttle is a reusable spacecraft which launches a crew in orbit to do in-orbit research in zero and low-gravity environments. And the space shuttle itself the shuttle is launched into space using different boosters in different stages. And the shuttle itself would then orbit around the Earth for the duration of the mission. And then once the mission is done, would fly back down into orbit and then be able to be reused. And because the shuttle was able to be reused, there were only 5 of them constructed, the first of which being the Columbia Space Shuttle. 7 astronauts on board for this mission were Rick Husband, William McCool, Michael Anderson, Kalpana Chawla, David Brown, Laurel Clark, and Elon Ramon. And they were all sent up with various specialties and various missions for what they were planning to do in orbit. However, they all had similarities in the fact that they were mostly Navy and Air Force pilots, so they knew what to do under pressure and were able to adapt to many different circumstances. Now, the Columbia was the first space shuttle to explode since the Challenger incident in 1986. However, what differed from the Challenger is that the Challenger exploded on the ascent portion, while the Columbia exploded on re-entry, which opened a whole new can of worms for people trying to figure out how this could happen. The consequences from this is that the space shuttle program was delayed for 2 years, which in turn delayed progress in the International Space Station as no missions could be sent up to expand on the space station, which kind of led to a decrease in space exploration for this time. The incident itself was caused by a piece of foam breaking off 82 seconds after takeoff, which then hit wing at 500 miles an hour, which caused damage, which on re-entry and the heat from re-entry would cause the Columbia to blow up. And now to talk more about the technical reasons and the engineering failures for this is Brian.
Okay, so initially, when you hear foam debris, it sounds kind of harmless and like it wouldn't affect such a large, complex operation. But we need to understand that the aspects of reentry are really like unstable and unpredictable. So it's one of the most dangerous parts about spaceflight. So when an object enters the upper atmosphere from orbit, it's initially traveling at close to 25 times the speed of sound. And this high speed causes a lot of friction from the air resistance. And just to think about how hot things would be getting, rub your hands together and imagine that, a couple 100,000 times hotter. and you can have an idea of how hot it's getting up there. And these temperatures are so great that not only can they cause the actual components of the ship to melt and fall apart and weaken, but they actually heat up the air around the craft so much so that the molecules break apart and form a plasma cloud around the space shuttle. So it just goes to show you how dangerous this part of the space flight can be. And NASA has dealt with this in a variety of ways. Um, so initially, NASA used to use ceramic, like burnable materials that would simply burn off uh, to protect the actual permanent components of the capsule from uh, undergoing any actual damage. But this doesn't really work with the space shuttle because it needs to be reused multiple times. So NASA created these ceramic tiles for the wings and nose tip. And as you can see on that diagram, those are the parts experiencing the most heat under reentry. And these are really delicate pieces, and it's a really like complicated process with how the material science aspects of these ceramic tiles work. So even minor damage like that foam can cause little holes that completely change the resilience of these tiles. So in the Columbia's failure specifically, the piece of launch debris created tiny little holes where uh, similar to the ones that are on screen now. They're not quite the same because we obviously don't have any pictures of what the Columbia looks like afterwards, but it would look approximately the same size and the same kind of breakage. So these little holes would allow like hot atmospheric gases and plasma to penetrate into the wing, which would allow the entire space shuttle to lose control. And unfortunately, after they lost control, all of the other parts of the spaceship followed suit and were exposed to even higher temperatures, causing a chain reaction, causing the entire shuttle to fail. And this led to the disaster. Now I'm going to turn it over for how this oversight affected NASA and what we learned from it.
Sweet. Thank you, Simon. Or Brian, sorry. Yeah, so as Brian and Simon mentioned, a piece of foam debris fell off the Columbia and it led to the explosion on reentry. But what they didn't really get into was that NASA failed to undergo a significant investigation when the Columbia launched. So whether there's a potential of an issue or not, there should be an investigation, of course, while they're in space to test for if there could be issues on reentry. And that just boils down to that whenever there's a human life at risk, all precautions should be taken to avoid fatality, which is something that agrees with the ethical codes of both deontologicalists and the utilitarianism mindset. So deontological ethics point towards a moral code, a universal law. And for example, that would be don't hide information or don't lie. And this information of foam debris falling off on flight into space was hidden from both the public and the crew. So on their way back, the crew was not able to find peace before their death because the information was hidden from them, and there was no chance of a like miracle solution because they assumed that there was no way to fix things, and they were just doomed from if the debris had fallen off. And that kind of points towards the utilitarianism side, that which is the focus on good outcomes for the most amount of people. Because senior management on this mission, they wanted to save themselves from the embarrassment of having to admit to the public that there could have been an issue on something that is not necessarily fully approved by the nation that we should be pumping and funding money for space. Um, so they failed to undergo this serious investigation, and then the bad outcome of 7 deaths happened just for the sake of 3 management positions feeling like they might be embarrassed if they had to admit this. And that also revealed an issue to the public and resulted in action, which Simon had mentioned, the riskiness and lack of safety associated with the space shuttle, because the space shuttle was really a product of the Cold War, because we were really moving into the space we were moving into the space race, and global superpowers were fighting to have political dominance over each other. And that's why the moon landing was such a big deal, because the USSR, the US, China, they were all looking towards space. And this was a byproduct. The space shuttle was because we wanted to continue to keep pushing forward. And we were blinded by ambition because we were very ambitious. We wanted to move into space, be dominant there. So we weren't really looking at the risk associated with space travel, which there's a lot of variables that goes into space travel, a lot of things that can go wrong. And we were just pushing forward and forward, which makes sense because both management wants to look better, wants to move up in their positions. And then these people that are researching it are passionate about it. So as you see in the left side, we have the Challenger disaster, and we didn't learn from this. We didn't learn that there's issues with space travel and we really need to slow down. But now, as you see the wreckage, the small amount of wreckage that we were able to get from the Columbia, you see that there is a great deal of risk that this huge space shuttle was diminished to this, and 7 people died. And now in response to those fatalities, as Simon mentioned, we shut down and retired the space shuttle program for a while. And eventually, with enough focus and enough meticulous effort and focusing on safety, SpaceX was able to launch the space taxi within the last decade. And then outside of design changes, if we look at the consequences, you also see the remodeling of the working environment at NASA, because as I mentioned, the working environment is very focused on pushing forward. And now they realize that we need to sit back a little bit. And they really held one person responsible on this internal investigation where they internally changed things, and that was Linda Ham. Linda Ham was rightfully demoted and removed from her position in management. And she was, I guess I should first get into who she was. And she was like the senior manager on the Columbia team, and she was overseeing the mission. And she exhibited an attitude of avoidance towards inspecting into what could have happened on the way up, and if there was an issue on the way up. And that ultimately led, with this willful ignorance, putting herself first, to these 7 fatalities that we have mentioned so many times and deserve to be mentioned. So that was the first change in NASA, along with, of course, the working environment. But there really was nobody that was purely to blame, because it was an engineering, not necessarily fault, but something that goes wrong because there's so many variables to deal with. So really the blind ambition is to blame. So overall, this disaster was vital in bringing attention to the recklessness and the carelessness that goes into tense international conflicts. And we really sat back and we took a step to see that space travel needs to be dealt with more meticulously. Thank you.